In my struggle to learn the basics of cybersecurity, even if I do possess the mindset and a bit of surface experience, I'm still lacking in the technical skills and abstract understanding that stems from this field, as cybersecurity is a mile wide and a mile deep. While trying to make things more easy to understand and more interesting for myself, I've realized that it would greatly help if I'm somehow combine it with hands-on electronics to experiment with. Now enter a tool named Bjorn, which provides some understanding on how a network scan works and what vulnerabilities can be discovered with it. I've linked the GitHub page down below and cheers for its developer. For transparency, I will also reveal what mistakes I did during this project. As a disclaimer, I have to state that this video is intended for educational and defensive purpose only, and any type of Wi-Fi scanning or sniffing should not be done on someone's network without approval and should be performed only in a personal controlled environment. From what can be observed around us, the digital environment is linked together. Cybersecurity, at least the very technical branches of it, not the paperwork field entitled GRC, is actually a combination of all the IT fields, from programming, malware analysis, system administration, networking, radio frequency analysis, and electronics, all these combined as a whole in a mindset that can be either defensive or offensive. From my perspective, the offense is complementary to defense and vice versa, but not as a general rule or path to follow in your learning journey. Also, I would say that the most important foundation in cybersecurity from a technical standpoint is networking. The OC model in layers defines the standard on how different communication systems are connecting to each other. This is a very deep rabbit hole on its own, but it's a fundamental one. As a brief presentation, the physical layer, hardware, cables, devices, and so on, this layer can be impacted by data sniffing. This is how some Wi-Fi passwords are being breached. The data link layer, which manages the data transfer, this can be impacted by spoofing, which is faking information like IPs, emails, MAC addresses to closely resemble or appear as the original. The network layer, this handles the data packets being transmitted. This layer can be impacted by the man-in-the-middle attack, which is someone who intercepts your data between you and the recipient. The transport layer, this handles the end-to-end communication and data integrity. This can be impacted by reconnaissance and DOS attacks, someone who is gathering informations about your device running services, ports, or does a denial of service attack which basically overwhelms your traffic with data, thus triggering a connection malfunction. The session layer disestablishes, maintains, and terminates connections, can be impacted by session hijacking. Like for example, a man in the middle who is attacking your network layer steals your browser cookie session for an online account and uses it at its own to access it. The presentation layer, which translates data formats and manages encryption, for example JPEG files in an email. This layer is usually impacted by phishing, which is intended for credential theft and most common attack vector. And last one, the application layer. This is the interface of any application you use and can be impacted by exploits. For example, a web page which is injected with malicious code that downloads a malware in your computer when you access it. So each layer in this chain comes with a vulnerability and can be impacted by multiple attack vectors. From a networking standpoint, if I'm not mistaken, Bjorn operates mainly on layer 7 and layer 4. Now for the actual parts and details and setup of Bjorn. The Raspberry Pi Zero should be W or version 2. Getting to the electronic ink display, which is around 20 euros and should be 2.13-inch display under version 4 or 2. Version 1 and 3 were not tested. So make sure you get the correct version to avoid any surprises. The connection pins for the P should be 2.5 millimeters one. You will have to solder them. If you do not have any experience with electronics, this is a good way to start, but make sure you exercise your soldering beforehand and handle the components by the sides to prevent static discharge or damage. As an alternative, you can buy the P with the pre-soldered pins. In this project, I encountered difficulties with my Raspberry unit because a few holes remained stuck with solder when I removed the old pins that were attached by the previous owner from which I bought the P. I didn't have the right tool to remove the old solder, and I've used a wooden toothpick, which was a very tedious operation and took too much time, and I was afraid I had damaged the transistors on the other side by overheating the board. Fortunately, that didn't happen. The printing of Bjorn enclosure was a success. With this Viking style model, although it looks cool, it overcomplicates things a bit because you'll have to solder directly on the copper pads to power the P, as there is no USB access on the sides of the enclosure. It was probably designed this way to hide the wires behind for aesthetics. There is also another enclosure model which is more efficient in design and looks more professional, but obviously it does not look like a Viking soldier. The copper pads to solder the power wires sit directly under the micro USB power slot. The one with the small dots is 5 volts defined as PP1 and the other one PP6 is ground. But as a safety measure, this should be measured with a multimeter set on continuity symbol and touch with the black probe the exterior side of the HDMI metal case and the red probe to the PP6 pad. If you hear a long beep, it confirms the ground pad. At the end, the P should look something like this. I added some glue to make sure the wires will remain in place. When you connect it to the display, make sure to align it correctly. The display ribbon should be parallel with the P card slot, then press firmly as it snaps in quite difficult, preferably on a flat surface starting with the corners. The OS is easy to install on a 32GB microSD. You will probably need one of these cheap USB adapters for the card. Next, you download the Raspberry Pi imager. The procedure is straightforward. It will ask you to choose the P version, in my case 0W. The Raspberry Pi Lite 32-bit OS version is found in Raspberry Pi Other. Give a name to your device, choose your location, create an username and password, associate it with your Wi-Fi network, enable SSH for remote and authentication and password for security. Next, Raspberry Connect can stay off. Click right, understand and initiate. It will take a few minutes to complete. Take the card out and insert it into the Raspberry. Before mounting it into the enclosure to avoid any surprises, I've powered it up through the USB to make sure it works. From the start, the green LED has to flicker for a minute or so before remaining constant. This will indicate that the OS booted successfully. Since the light version of Raspberry OS does not offer any GUI interface, the only way to control it is through SSH, which is a secure remote connection protocol. If you have a hard time learning and understanding the commands, almost any chatbot can help you in this direction if correctly prompted. I know there is a lot of backlash against AI and most of it is clearly justified, but at least on a basic level, any decent chatbot would be useful. You can SSH into the Raspberry by user and device name that was added when the OS was installed or by the IP address. In my case, connecting with the device name only failed for an unknown reason and I had to connect through the IP. In order to find your Raspberry IP, the easiest way would be to log into your router because when correctly configured upon installation, the Raspberry should automatically connect to your network upon boot up. Depending on your router model, it should be somewhere under user device and not hard to find. Now, in my opinion, this method is the best because if your Raspberry is not detected by the router, it means something is wrong either with the unit itself or the OS configuration or both. To connect, simply type in any terminal your device username, in my case SSH Chris88192168100120. You will receive a security warning, type yes, then it will ask for the device password and success connection established. Next, copy and paste the command from Git. Select one for full installation, then we will prompt for display version, in my case 4. And again, I've encountered some errors. The Bjorn software is optimized for Raspberry OS 12 bookworm, and the Raspberry Imager automatically deploys the latest OS, which is 13 Trixie. My mistake. So I rewrote the SD card with the legacy version Raspberry bookworm. Nothing complicated, but be aware if you are not used with Raspberry OS or Linux in general, always make sure the OS version is compatible with whichever repository you are planning to use. This time everything went smoothly. It took like half an hour to install, reset at the end, and success. Bjorn is functioning. SSH back into it, go to your browser, type HTTP, the device IP, and port 8000, and a very awesome interface will show up. For experimenting, I've acquired a variety of cheap IoT devices to audit: a camera, a smart socket, a smart light, a humidity and temperature sensor, and a universal remote control, all connected to a personal SIM card LTE router. Obviously, the Bjorn has to be connected to the same network with the IoT devices. If someone would use this tool offensively on your network, he would first have to know or breach your Wi-Fi password using other techniques or tools. Okay, so I'm logged into Bjorn. I've played with it a bit, but I haven't tried all the attacks because I do not understand yet how everything works. However, I will provide a brief example on what I've managed to discover with it. We have here the network scan that detects the devices, their IPs, their MAC addresses, and what ports are being detected as open. An attacker, once inside your network, will try to scan the IP, identify the device by the MAC address, and also exploit the open ports. So my first step was to find out what exactly is port 23. This is a telnet unencrypted service protocol. So basically a backdoor into the device which allows total control over the camera. It is not intended for user login and it should not be running. It is primarily used in the factory when they test the camera. If someone would breach your network and find this port running, this will be their main target. I've used the nmap command nc-v to test if the port is open and if it replies, and apparently it does by requesting the login credentials. I do not have these credentials, so I've played around with some basic ones. I've also tried the Bjorn's telnet brute force attack, but for some reason it failed, and from my understanding the attack itself is a dictionary basic one. Since I'm running ParrotOS, I've tried the Hydra brute force dictionary attack, but again I didn't have any success with it. Next, I've tried with nmap svp23 command to find out exactly which version of telnet this is, and apparently it states many brands. This would point to a generic firmware. I've also tried to scan with nmap-o and I've received multiple interesting results regarding other ports which are being detected on the device and its operating system. This is just the tip of the iceberg because an attacker would run very complex scanning techniques on these ports and most likely combined with stronger dictionary brute force attacks to breach the port 23 credential login. I will try myself to breach this camera, and if I will succeed, I will post an episode about it. I hope this brief presentation provided some value in certain cybersecurity basic steps, and see you next time.